Hey everyone, imagine you're out in space, super far from home. To get back to Earth, you'd have to travel for many years. But what if there was a secret tunnel in space that lets you jump and arrive almost right away? That magic tunnel idea is called a wormhole. You've probably seen them in movies, a glowing circle, a tunnel, the ship goes inside and reappears somewhere else entirely. Today, we're going to find out what a wormhole actually is, why scientists talk about them, and if they could be real or are just awesome science fiction. To understand wormholes, we first need to think about space and time in a new way. Imagine space and time woven together like a huge, stretchy blanket or a trampoline. Now, if you put a heavy bowling ball on that blanket, it makes a big dent, right? That bowling ball is like a planet or a star, and the dent it creates is how it bends space around it. If you roll smaller marbles nearby, they'll curve and fall toward the dent. The rolling is just like gravity pulling things in. The heavier the object, the deeper the dent, and the stronger its gravity. Normally, to get from one spot to another, you have to travel across the surface of the blanket, following all its curves. But a wormhole would be like a special tunnel that punches right through the blanket, connecting two places that are far apart on top but super close through the tunnel. Here's a really easy way to picture this. Grab a sheet of paper, draw one dot on the left side and another dot on the right side. Let's say these are two far away places in space. If you're a tiny ant traveling on the paper, you have to crawl all the way across from one dot to the other. But now, what if you fold the paper so the two dots touch each other? If you could poke a tiny hole right where they meet, you could jump from one dot to the other in basically no time at all. That little hole is exactly like a wormhole, a shortcut through space-time. So let's put it all together. A wormhole is a tunnel through the fabric of space-time, with two openings called mouths and a tunnel in the middle called the throat. One mouth could be right here, near our solar system. The other mouth could be incredibly far away, maybe near another star, in a whole different galaxy, or even some other strange region of the universe we can't even imagine. If you could enter one mouth, travel through the throat, and pop out the other side, you would have used a cosmic shortcut. Instead of flying for thousands or millions of years through normal space, you jump through the tunnel in a very short time, at least in theory. So, where do these incredible space tunnels even come from? Well, you can't just spot a wormhole with a telescope. They were born from the mind of Albert Einstein and his groundbreaking theory of general relativity. This theory completely changed how we see gravity. It's not a force pulling things down. It's actually space and time itself bending and warping around massive objects. When scientists explored the math of general relativity, pushing it to the absolute extremes with super strong gravity, they found solutions that looked like tunnels connecting two different points in space-time. The very first of these mathematical wormholes was called an Einstein-Rosen bridge. It described a link between a black hole, a cosmic one-way door, and something called a white hole, which would act like an exit. But there's a huge problem. These bridges are incredibly unstable. The math shows they would collapse in on themselves so fast that not even a beam of light could make it through. Later, scientists imagined a different kind, called traversable wormholes. These are the ones you see in movies, tunnels that could theoretically stay open long enough for something or someone to pass through. But to prop open this cosmic shortcut, the equations say we'd need something truly bizarre, exotic matter with negative energy. And that's something we've never found in the real world, at least not in the amounts needed to stabilize a wormhole. This brings us to the big question. Are wormholes real, or are they just a cool idea from a physics equation? For now, they remain firmly in the cool idea category. They pop up in the math, and they're fantastic for asking what-if questions about the universe. But despite all our searching, we have never ever observed a wormhole out in space. We have no idea if the universe actually makes them, or how we could ever build or control one. Some scientists believe wormholes might just be a ghost in the machine, a quirky result of our current equations not being the full picture. Others are more optimistic. suggesting that maybe microscopic wormholes are constantly flickering in and out of existence at a scale too small for us to see. But the honest answer is we just don't know. They are completely hypothetical. Now let's clear something up. Wormholes and black holes get mixed up all the time, but they're very different. A black hole is a real object out in space, where gravity is so intense that once you cross its event horizon, you're never getting out. It's a one-way trap. We have tons of evidence for black holes. We can see their effects on nearby stars, and we've even taken pictures of their shadows. A wormhole, on the other hand, is a theoretical tunnel connecting two different places. So think of it this way. A black hole is a destination of no return, while a wormhole is a potential shortcut. Right now, black holes are real, and wormholes are still just an idea. And finally, the question everyone wants to know. Could we actually travel through a wormhole? If, and this is a huge if, a stable wormhole existed, you could theoretically fly your spaceship in one end and pop out light years away on the other side of the galaxy in an instant. But making that if a reality is the problem. To keep the tunnel from collapsing, we'd need that exotic matter with negative energy to act as a scaffold. We have no idea how to create or handle that stuff. Plus, we'd need to control where the wormhole's entrances are. So for now, traveling through wormholes is pure science fiction. It's a fantastic idea for movies and books, but not something you'll see on NASA's mission schedule anytime soon. Wormholes get even wilder when we add time into the mix. Imagine one end of a wormhole is moving super fast, or sitting near something with really strong gravity, like a black hole. According to Einstein's theories, time would actually slow down at that end. This is a real thing called time dilation, and we've actually measured it using super precise clocks and satellites. So if you took that fast-moving wormhole mouth and brought it back next to the stationary one, their clocks wouldn't match up. One end would be older and the other younger. In theory, this could turn the wormhole into a time tunnel. You might be able to jump into the future, or even travel back to the past, at least as far back as when the wormhole was first created. But this leads to some serious brain benders, like the famous grandfather paradox. What if you went back in time and accidentally prevented yourself from ever entering the wormhole in the first place? Because of these confusing paradoxes, many scientists believe that the laws of physics probably have a built-in safety feature to stop this kind of time travel from ever happening. So if we can't see wormholes and probably can't travel through them, why do scientists even bother studying them? Well, it's because wormholes are an amazing mental workout for our understanding of the universe. They're a fantastic tool for testing the limits of our biggest theories like general relativity and quantum mechanics, and seeing where they might break down or contradict each other. Thinking about wormholes forces physicists to ask new and deeper questions about black holes, dark energy, and the very first moments of the universe after the Big Bang. Sometimes, these what-if scenarios, these seemingly crazy ideas, are exactly what science needs to leap forward. Even if we never find a real wormhole, the process of imagining them helps us discover new truths about reality. In science, imagination isn't just for stories, it's a powerful tool for discovery. Alright, let's wrap this up. A wormhole is basically a theoretical tunnel through space and time, a shortcut connecting two very distant places. While the math in our best physics theories says they could exist, we've never seen one, and we have no idea how to build one. They would require some really exotic, weird stuff to stay open, and would likely be incredibly unstable. Remember, black holes are real, confirmed objects. Wormholes, for now, remain an exciting idea. Still, they are amazing to think about. They remind us that the universe is probably way stranger and more wonderful than we can even imagine. So the next time you see a spaceship dive into a glowing tunnel in a movie, you'll know the truth. It's an idea rooted in real scientific questions, but for now, its home is in our collective imagination. Thanks for watching, and don't forget to like and subscribe for more space adventures.